Welcome to the Keeping It Simple series for biochemistry. On this lecture, we're going to cover enzyme kinetics and naming. Let's begin by talking about enzyme function. What do enzymes do? I'll give you the overview now. We'll talk about details in a second, okay? It gathers up all of your substrates and it lowers the free energy of activation. And we'll talk about that more in detail now, but realize and see that it's red because that's important, all right? So enzymes lower the free energy of activation. They control the high energy intermediate. They are not destroyed by the reaction, and they make improbable reactions more likely. Understand? They make them more likely. So think about boiling a pot of water. All right, water, that's your substrate. All right, your enzyme is your salt. Right. So what happens when you put salt into the pot? It boils quicker and at a lower temperature. Okay, so the reaction there is the boiling. Now, without the salt, you can still boil that water. It will just take longer for you to boil it, right? So all this did is sped it up and it lowered the temperature at which it happened. The salt, okay, if you turn it off, right, you can evaporate the water and the salt will still be left because it is not consumed by the reaction, all right? There's an example. And it stabilizes what we call the high energy intermediate because if you add salt, what that does is it prevents something from boiling over and out of the pot, all right? So salt there is your enzyme. Now, here's a picture. Now you see the high energy intermediate, and then you see an arrow. And it says free energy of activation, right? The analogy we use here is a hill. What's quicker to climb, a small hill or a big hill? Well, that's what it is, all right? All we're doing is we're making that hill a little bit smaller so that reaction doesn't have to climb the big hill. Now, enzyme structure. All enzymes are proteins, which means that they are made from amino acids, which means that it requires the activity of replication, transcription, and translation. All enzymes have two sites, the active site and the regulatory site. The active site is where the substrate binds the enzyme. It's blocked by competitive inhibitors. Competitive inhibitors, okay, block the active site. Competitive inhibitors block the active site. Competitive inhibitors block the active site. They block the active site, and you measure this by Km or affinity or potency, and we'll talk about that later, all right? The regulatory site regulates the enzyme and allows the enzyme to work, and it is blocked by non-competitive inhibition. So non-competitive inhibition blocks the regulatory site. So regulatory site, non-competitive, active site, competitive. Active site, active site, non-competitive, regulatory site. Excellent. All right. So if you don't have DNA, you don't have mRNA. If you don't have mRNA, you don't have a protein. If you don't have proteins, you don't have enzymes. If you don't have enzymes, you have no biochemistry, which means you will not have energy because the goal of biochemistry is to give you energy. All right? Enzymes. So let's talk about Km and what happens if it decreases or increases. Km has an inverse relationship to affinity. That means if Km goes down, affinity goes up. And if Km goes down, then affinity goes up. But if Km goes up, then affinity goes down. Right, so it's an inverse relationship. So affinity and potency always go in the same direction. They go in the same direction. So if affinity increases, potency. If potency increases, then affinity. Excellent. So if Km goes down, affinity goes up, and potency goes up. So if Km goes down, affinity goes, potency goes. So if Km goes down, affinity goes, potency goes. Excellent. And that means the enzyme is more active. That means that there is more substrate around for the enzyme to act, or there are more open sites on the enzyme for the same amount of substrate to bind. All right? If Km goes up, that means affinity goes down, inverse relationship. So if Km goes up, affinity goes down. If affinity goes down, then potency goes down. And that means the enzyme is competitively inhibited. Okay? Competitive inhibition means that Km goes up. So that means in competitive inhibition, affinity will go, potency will go. So in competitive inhibition, Km goes, affinity goes, potency goes. Excellent. That's because the inhibitor is competing with the substrate for the active site, and that means there are less open sites on the enzyme for the substrate to bind, which means if we add more substrates, okay, it becomes reversible. We did Km, now we got to talk about Vmax. Okay? Vmax is the maximum velocity at which the enzyme can carry out its activity at that time. All right? So it's like the speed. Okay? How fast can that enzyme work? If Vmax goes down, efficacy goes down. If Vmax goes down, efficacy goes down. Vmax goes down, efficacy goes down. Excellent. And that means this enzyme is non-competitively inhibited. Understand? So in competitive inhibition, Km went up. In competitive inhibition, Km went up. But in non-competitive inhibition, Vmax went down. So in non-competitive inhibition, Vmax went, which means efficacy went. Excellent. That's because the inhibitor is binding to the regulatory site, which means the enzyme now can carry out the reaction, but at a lesser velocity or at a slower speed. That makes this reaction harder to complete. And it's harder to complete, which means it is irreversible. Okay? So if you see Vmax going down, efficacy going down, and the word irreversible, you think non-competitive inhibition. If you see Km going up, affinity going down, potency going down, and the word reversible, you think competitive inhibition. We beat that horse to death, but it's important. Okay? They're easy points on your test, so don't miss them. Okay? It's easy to get mixed up. That's why we drilled it. So, non-competitive messes with Vmax, which means it decreases efficacy. That turns the enzyme off at the regulatory site. And because you've turned it off, you can't turn it back on, which is why it's irreversible. Okay? Vmax and Km. Here's a graph. Vmax is on the y-axis. Substrates on the x-axis. Okay? Remember, Km is 1/2 of Vmax. Km is? 1/2 of Vmax. Excellent. And that's why with this series, we have practice questions. So you can go in, watch the video, and then take a quiz to make sure you can manipulate this graph. The one trick I will tell you is this. Okay? Watch your Km. If it goes up, you pick competitive. Vmax goes down, you pick non-competitive. All right? Watch your axis, because I'd love to switch the axis around. Rate-limiting enzymes. And later today, we're going to do the summary of anabolic, okay? And we're going to talk about rate-limiting enzymes, what inhibits it, what promotes it. For this video, rate-limiting enzymes are the slowest enzymes in the pathway. That means, okay, that they have the lowest Vmax. Why? Because Vmax, we said, was speed, right? These are the slowest, so they have the lowest Vmax, which means they also have the highest Km. So they have the highest Km and the lowest Vmax. So rate-limiting enzymes have the lowest Vmax. They have the lowest, Vmax. But they have the highest, Km. Which means they require more energy, and they're often irreversible, and they always have a sigmoidal curve. All right? Rate-limiting, remember the S's. S for slow, S for sigmoidal, S for substrate, it needs a lot of substrate, and S for strong, which means it's irreversible. All right? Non-rate-limiting enzymes are faster enzymes in the pathway, which means they have a high Vmax and a low Km, and they require little or no energy. Okay? These are often reversible, and they have a linear curve. Okay? So non-rate-limiting enzyme, the L's, linear, less energy, low Km. Okay? Lightning speed, they're faster, and loose, they don't bind as strong, so they're reversible. Now we're going to talk about Gibbs free energy. I like this Gibbs free energy analogy. Okay? I'm going to give credit here to Dr. Kyle Velthaus for coming up with this. Delta G equals delta H minus T delta S. So Gibbs free energy, delta G equals delta H minus T delta S. What does all this stuff stand for? The delta G is Gibbs free energy. The change in H, or delta H, is enthalpy. T is for temperature. And S is for entropy. Okay? I'm going to explain all these here in a second. So, Gibbs free energy. is the energy that must be overcome for the reaction to occur spontaneously. I didn't say it must be overcome for the reaction to occur. I said it must be overcome for it to occur spontaneously. There's a difference. So this is a measure of whether a reaction is likely to occur. A negative delta G means the reaction is more likely to occur as it needs less energy. A positive delta G means the reaction is less likely to occur as it needs more energy. Anybody here watch NCIS? Familiar with the show? Okay. So analogy I'm going to give you deals with that show. So Gibbs reminds me of NCIS and the Gibbs slap. If you watch the show, he slaps people on the back of the head like this. The slap is a spontaneous action that occurs when Gibbs is in a bad mood. He slaps people when he's in a bad mood. Understand? G is for Gibbs, right? And G, when it changes, when the mood changes, okay, you get a reaction if the mood is worse. Understand? So if delta G is negative, Gibbs is in a bad mood. He's likely to slap somebody. Understand? Everybody follow? All right. So if it's worse or negative mood, the slap is more likely, but we can't say for sure that'll happen. Gibbs could be really, really pissed off, but he may not slap you. He's more likely to slap you, but 100% of the time we don't know if he's going to do it or not, right? We can just say that, hey, if he's mad, he might slap you. He's more likely to slap you. But if he's in a good mood, if he's in a better mood or a positive mood, if delta G is positive, the slap is less likely because he's happy. He's probably not going to slap you. But we can't say it won't occur. He might do it anyway. But all we know is this. If delta G is negative, he's in a bad mood, that slap or that reaction is more likely. If delta G is positive, he's in a good mood, that reaction is less likely to occur. Enthalpy. Delta H is enthalpy. Enthalpy is the heat required or released by the reaction. Heat is a form of energy. Now, let's think about enthalpy as the difficulty of the case the NCIS team is working on. And NCIS stands for Naval Criminal Investigative Services. So if you haven't seen the show, they investigate these homicides and things that happen to people in the military, specifically the Navy. So let's talk about enthalpy and relate it to the difficulty of the case that this group of people is working on. If the case is more difficult, the heat is on. And Gibbs is more likely to be forgiving. Right? You make a mistake, but it's a hard case. You might be like, okay, you know what? It's a hard case. I understand. I forgive you. Okay? But the heat is on, so it gives you a little bit of room. So we have two terms you have to know. The first term is exothermic. The second term is endothermic. Exothermic. This is an easy case. The team can blow off steam. But Gibbs is going to be less forgiving. Why? It's an easy case. You can't make a mistake on an easy case, right? You shouldn't. So that means if it's exothermic, it's an easy case. The team can, let's say, blow off steam, give off heat, right? But because it's an easy case, Gibbs is not that forgiving. Okay? So that's a negative delta G. He's more likely to slap you than if you make a mistake. Because it's an easy case and you shouldn't make one. Endothermic, now this is the hard case. It means more of the team's time and energy. It's a hard case. Gibbs is going to be a little more forgiving because it's a hard case. And because he's more forgiving and it's a hard case, that reaction is less likely to occur because Gibbs is positive. Understand? So exothermic, negative delta G, more likely for the reaction to occur. Endothermic, less likely for the action to occur, and a positive delta G. Now, a positive delta H, we talked about the analogy, let's talk about the actual biochemistry, right? A positive delta H means more heat is required by the reaction. Understand? That means endothermic. It takes in heat, it requires more energy, and because it requires more energy, it makes that reaction less likely to occur. A negative delta H, that means it releases heat, It's exothermic. Less heat is required by the reaction. It requires less energy, which makes the reaction more likely. Okay? Talk about Bengay. Bengay contains menthol. Okay? When rubbed on the skin, it causes an exothermic reaction. It releases heat. This makes the skin feel warm. The heat vasodilates. More oxygen comes in. More blood flow comes in. You heal quicker. Peppermint-flavored cough drops cause an endothermic reaction. They take in heat, making your mouth cool and minty fresh. All right? T is for temperature. The amount of heat that is already available in the environment. And the reaction can use this as energy. A positive T means there's more heat available from the environment, and that means that the reaction can more easily overcome enthalpy, which means the reaction is more likely to occur. Okay? Negative T means there is less heat available from the environment, which means it's more difficult for this reaction to overcome enthalpy, which means the reaction is less likely to occur. So we go back to our Gibbs analogy with NCIS. Temperature is like Gibbs' temper. All right? The mood he is already in. A measure of the environment at that time. Bad mood, high temper, easier to set off. Easier to get a slap, more negative, delta G. Good mood, lower temper, lower temperature. Less likely to set off, less likely to get the slap, which means our delta G is positive. All right? Now here's a graph. You see on the y-axis it has Vmax, on the x-axis it has temperature. As temperature increases, so does Vmax. And then you reach a point where the temperature is too high, and the proteins start to denature, and this kills the enzyme function, and you see the Vmax go down. Clinical correlation. Let's talk about fever and hyperthermia. Fever and hyperthermia, body temperature goes up. This increases the Vmax of all of your enzymes, which makes the reactions more likely to occur. Until about 42 degrees Celsius or 106.6 degrees Fahrenheit, when enzymes start to denature, the reactions then become less likely to occur because we have no enzymes. This is why we tell people, listen, you got a fever, don't give Tylenol or NSAIDs until the temperature is over about 100.4 degrees. Because temperature in your body does at some point speed up your enzymes and help you get better, right? IL-1, etc. And if somebody has a fever, the best way we can treat them is, the best way we can cool them down is by vaporized cold water. Okay, vaporized cold water. Hypothermia, on the other hand, means you have decreased body temperature. This decreases the Vmax of all of your enzymes, making the reactions less likely to occur. Mild hyperthermia is between 89.6 and 95 degrees Fahrenheit. Moderate is between 82.4 degrees Fahrenheit and 89.6 degrees Fahrenheit. Severe is below 82.4. So you treat these people with a gradual rewarming. You'll remove their wet clothes. You'll give them blankets. You'll give them warm liquids orally. If it's mild, IV, warm liquids if it's moderate or severe. Okay? Entropy is a measure of randomness. Okay? Last part of our equation. Entropy is a measure of randomness. So in NCIS, there's a character, his name is Tony. Okay? Tony's one of the agents. And Tony's always doing dumb stuff. And every time Tony does something stupid, Gibbs comes back and slaps him on the back of the head. Okay? If you guys watch the show, you'll see it happen. So, entropy is like the stupid stuff, the stupid random stuff that Tony does. Okay? He's one of the recruits that's being trained. And it's the stupid stuff that he does to deserve getting slapped. So, more random, the more stupid stuff he does, the more likely he is to get slapped, the more likely that reaction is to occur. If he does less stupid stuff, he's less random, that reaction, okay, is less likely to occur. He's less likely to get slapped, okay? In real life, reactions occur. It's easier to happen in gases. It's moderate in liquids and difficult in solids because of entropy. The degree of randomness is highest in gases, then liquids, then solids. So gases, reactions will occur easily in gases, then liquids, and then solids will be the toughest. Phosphate groups have a lot of negative charge on them, making them unstable. This is because like charges repel, whereas opposites attract. So when you bring lots of negative charges together, it creates a lot of energy, okay, like ATP. And we'll talk about ATP throughout biochemistry. So entropy is a measure of randomness. A positive delta S means the environment is more random. The environment already has a lot of energy in it, so you need less energy to overcome, which means that reaction or that slap is more likely to happen. If delta S is negative, that means the environment is less random. It has less energy in it, which means it has to have more energy to overcome, which makes the reaction less likely. Now, back to NCIS. You have your 3 team members. They're alone. Gibbs isn't around. They can get rowdy. Gibbs shows up, and they're more under control. Understand? The 3 team members are like phosphate groups, whereas Gibbs is more like adenosine. The adenosine plus the 3 phosphates make ATP. Understand? Okay? So when we exercise, we increase our metabolic rate and we start burning ATP. Most enzymes require about 5,000 calories to run. How many calories? 5,000 calories to run. Breaking one ATP, the first one off, gives you about 7,200 to 7,300 calories. Okay? The next phosphate gives you about 3,500 calories. Breaking off that third ATP will yield 1,000 calories of energy. There's only one organ in our body that will use all 3 phosphates of ATP, and that is the heart, because the heart is always working. Since the first phosphate group being broken off results in the production of 72 or 7,300 calories, and most reactions only need 5,000 calories, that means you will have excess energy left over after you exercise. Understand? This is why exercise can increase energy level for hours. Okay? So here's a summary for Gibbs free energy. The reaction is either going to be more spontaneous or is going to be non-spontaneous. If it's spontaneous, that means Gibbs and enthalpy are negative, and temperature and entropy are positive. Understand? So, in order for a spontaneous reaction to occur, Gibbs and enthalpy must be negative. Gibbs and enthalpy must be negative. Gibbs and enthalpy must be negative for it to be spontaneous, but temperature and entropy must be positive. So if you want a spontaneous reaction to occur, you want Gibbs and enthalpy to be negative, but temperature and entropy to be positive. If it's non-spontaneous, that's the opposite. Now Gibbs and enthalpy are positive, and temperature and entropy are negative.